Good day to each and everyone. This is Fieldwork exercise number 3, entitled Area Determination of Polygonal Field Using Tape. Introduction. A common problem for a surveyor is the calculation of the surface area of a specific field. The fields are often irregular, which makes direct calculation of their areas difficult. In such case, fields are divided into a number of regular areas, triangles, rectangles, etc., of which the surface can be calculated with simple formulas. All areas are calculated separately, and the sum of these areas gives the total area of the field. Before anyone starts to measure a field, he should first look at the field to see what shape it has. Traditionally, fields seldom have the simple geometrical shapes. The sides are often curved and the shape can be quite complex. In most cases, however, the shape of a field can be approximated by a simple figure. Curved lines can be approximated by straight ones, and the field can be split up into triangles and rectangles, which can all be measured and used to calculate the area of the field. Objective: it is to develop and acquire the skills of determining the area of a polygon in the field using tape by dividing the area into triangles. Instruments and accessories. We have wrench poles, measuring tape, markers, it's either chalk or marking pins, and plumb bobs. Number 1. The instructor assigns the location of 5 points in the field, and the students will mark these points with marking pins or chalk. Name these points, which will serve as the corners of the polygon, as A, B, C, D, and E. Number 2. The chief of party divides the polygon into 3 triangles by taking into consideration that the divisions should be easily measured. Name the triangles as A1, A2, and A3. Number 3. Measure the base of the first triangle chosen in the polygon using tape. Number 4. Then measure the length of the altitude of the first triangle. The determination of the altitude is part of taping operation, which will be discussed by the instructor. Number 5. Record the length of the base and altitude on table 3.1, area determination by base and altitude. To get the area of the triangle, divide the product of the base and altitude to 2. Number 6. Repeat steps number 3 to 5 for the chosen second and third triangles of the polygon. To determine the whole area of the polygon, take the summation of area of A1, A2, and A3.
The same field described in A, area determination by base and altitude, will be used for this method, but change the designations on the corners. For example, use F, G, H, I, and J instead of A, B, C, D, and E. Divide the polygon into 3 triangles. Measure any 2 sides of the first triangle chosen and record these measurements as sides A and B. Determine the included angle between sides A and B and record this on table 3.2 labeled as area determination by 2 sides and an included angle. To get the area of the triangle, divide the product of the side A, side B, and sine of the included angle to 1/2. Repeat steps 3 to 4 for the chosen second and third triangles of the polygon. To determine the whole area of the polygon, take the summation of areas of A1, A2, and A3.
The same field described in A, area determination by base and altitude, will be used for this method but change the designations on the corners. For example, use K, L, M, and O instead of A, B, C, and D, and E, and F, G, H, I, and J. Divide the polygon into 3 triangles. Measure all the sides of the first triangle chosen and record these measurements as sides A, B, and C on table 3.3 area determination by Herod's formula. Determine the semi-perimeter tree of the first triangle by multiplying the perimeter of the triangle by 1/2. To determine the area of the triangle 4, substitute the values of semi-perimeter side A, side B, and side C to equation 4, Heron's formula. Repeat steps 3 to 4 for the chosen second and third triangles of the polygon. To determine the whole area of the polygon, take the summation of areas of A1, A2, and A3. And this is our group work, the fieldwork exercise number 3.
End of flashback.